Okay, so repeating decimal expansions. From the book, a decimal expansion is repeating if, after some digit to the right of the decimal point, there is a finite string of consecutive digits called a block, after which the decimal expansion consists entirely of consecutive copies of that block repeated forever. All right, so I'm going to talk about one fraction, 1/3, which can be written as a decimal, which is 0.3, and then frequently what you'll see is 3 repeating. What this means is that there is a block, which is the digit 3, this is what it means. All right, this goes on forever. It never terminates. This is an infinite number. It goes on and on and on. But even though it never terminates, even though we could never finish writing out all these 3's, the value of this decimal is just 1/3. So what we do is we write the repeating decimal expansion, which is 0.33. Repeating, the bar above the top means repeating. And usually we put the bar over only the digit or digits that repeat. So it would be correct to say 0.3 repeating, but for some reason with 0.33 and 0.66, so 1/3 and 2/3, for some reason they're frequently written as 0.66 repeating instead of 0.6 repeating and 0.3 repeating. Technically the block is 1 digit long and repeats forever. So we can say 0.33 repeating, or 0.3 repeating, 0.66 repeating, 0.6 repeating, and these 0.66 repeating and 0.6, they mean the same thing. They're 2/3. Other times, let's see. Our curriculum doesn't give an example of a repeating. It doesn't, but I think I know one. So if we look at the quotient, well, okay, that's not a very good one either. But if we look at the quotient 1/9, we see that's equal to 0.111111, all right, or 0.1 repeating. One 1/12 is equal to 0.08333333. So we can write the 3 and then write repeating, and that indicates 0.8, 0.08333333, and so on. Okay, so here's a good example then. 1/7. fraction 1/7 is equivalent to 0.14287, and then this pattern begins to repeat. 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. All right, so because this pattern repeats, then this is the block which repeats, and the way that we write this is to say 1/7 is 0.14285 repeating. And that's a repeating repeating decimal expansion. All right, so a terminating decimal expansion. I can take a number like 1/4, and I can write it as 0.25000000. It doesn't matter how many zeros I put on there, okay? All of these digits are 0, and every number works exactly like this. But all these extra zeros are redundant, because if I say 1/4 is equal to 0.250, that has the same value as 0.2500000, okay? And then finally, even this has the same value as 0.25. So what is the terminating decimal expansion of 1/4? Well, it's 0.25, because that's all I need to represent the number. It's just these two digits past the decimal point. So it terminates at 2 digits past the decimal point, because I don't need any more. The rest of them are redundant.